Mic check 212. Mic check 212. 3, 4, and 5. Okay, we have an exam coming up on this coming Friday, and this is going to be a mini review of some topics that may appear on the exam. So let's talk about oxidation numbers and oxidation states. When we refer to oxidation numbers and oxidation states, we are actually talking about the same thing. So you may see something phrase, what is the oxidation state, or what is the oxidation number. In that case, you will know we're talking about the same thing. Okay. Rule number 1. In any neutral species that contains atoms of only one element, the oxidation number is 0. This rule is also referred to and is associated with atoms in their elemental state, sometimes called free atoms. Now, what we mean by that is an atom in its elemental state. And a very good example would be iron solid in its elemental state. It would have an oxidation number of 0. Hydrogen gas. Well, hydrogen gas is in its elemental state, and it would have an oxidation number of 0. Say phosphorus, P4, solid. P4, all atoms of the same type. It is neutral, so it would have an oxidation state of 0. Aluminum, solid, has an oxidation number of 0. Let me make this a little clearer. Aluminum solid has an oxidation number of 0. We have the same number of protons and the same number of electrons. Oxidation number of 0. Aluminum liquid, L, in its elemental state has an oxidation number of 0. So all of these examples have an oxidation number of 0. Cl2 gas in its elemental state, oxidation number of 0. Nitrogen gas in its elemental state, oxidation number of 0. Okay? So, let's look at rule number 2. For any charged species, the sum of the oxidation numbers of all the atoms in an ion is the charge of the ion. This is true for polyatomic ions and complex ions. So what that means is if we had phosphate, PO4, with a 3 minus charge, well, the sum of the oxidation numbers for one phosphate and 4 oxygens The sum of these oxidation numbers must add up to be a minus 3 or a 3 minus. We use those interchangeably. Those sum of these two oxidation states must sum up to be a minus 3. So if we do dichromate, Cr2O7 with a 2 minus charge. Well, the sum of the oxidation numbers for 2 chromiums and the oxidation number of 7 oxygens, those two must sum up together to give us a minus 2 or a 2 minus. Okay, and you will see exactly what I mean by that a little later. But know that a charged species contains the sum of the atoms, and it will have the charge of the ion. Okay, so the sum of the oxidation numbers of each atom is equal to its charge. Okay, rule number 3. For a neutral species, a neutral compound, the sum of the oxidation number must equal 0. So if we had water, which is what, molecular, but it is also neutral, the sum of the oxidation states for 2 hydrogens and 1 oxygen, they must add up to be 0. Okay? Now, if we had iron 2 iron 3 oxide. If we had iron 3 oxide, this is ionic. This is an ionic compound, but it is what? It is neutral. So the sum of the oxidation numbers for each atom must sum up to be 0. The sum of the oxidation numbers for two irons plus 3 oxygens, they must equal 0. Okay? Now you will see what I mean exactly when I do some examples. And I've also done a significant amount of these in class. Okay, rule number 4. The oxidation number for oxygen when it's in a compound is minus 2. Now there are some exceptions, but we will go by this general rule that oxygen has a oxidation number or oxidation state of minus 2. Since we haven't talked about electronegativity and the octet rule, we'll just keep it simple for this case. There are some exceptions, but in general we'll say the oxidation number for oxygen is minus 2 when in a compound. That does not mean that O2 has an oxidation state of minus 2. That does not mean O2 has an oxidation state of minus 2. O2 has an oxidation state of 0, going by this first rule. O2 gas would have an oxidation state of 0. This is a trick question, normally sometimes put on exams. Now, if I wrote SO4 with a 2 minus charge, the oxidation state of this oxygen would be -2. It's in a compound. If I had water, the oxidation state of this oxygen is -2. If I had dichromate again, the oxidation state of this oxygen would be -2. So just keep in mind right now we're just assigning oxidation numbers. Okay? We're assigning oxidation numbers in a compound or in a neutral species that only contains the atom itself. It only contains one element. So we see here we have different elements. PO4 with a 3 minus charge. The oxidation state for this oxygen would be -2 as well. Okay? So, just put this together real quick. And I believe your book has something similar to this. Rule 5, group 1A and 2A, we will say their oxidation states or their oxidation numbers would be respective to the group that they're in, +1 for group 1A, +2 for group 2A. So, sodium is in group 1A, and in this compound, sodium hydroxide, sodium would have a oxidation state of +1. Okay. Calcium hydroxide. In this compound, calcium is in group 2, a 2+ metal, so it would have a oxidation state of +2. And you will see what I mean by this a little bit later. Lithium fluoride. Lithium is a group 1 metal, so it would have a oxidation number of +1. Okay? Now the last rule is pretty easy to remember. The oxidation number of hydrogen in most compounds, and there are some exceptions, but for the most part, the oxidation number of hydrogen would be +1. HCl, oxidation number is +1. CH4, the oxidation state is +1. H2SO4, oxidation state for hydrogen is +1. So, I hope that you have gotten a hint as to what I'm doing. So the last example I gave you here, H2SO4. Well, we just said hydrogen has an oxidation state of +1, and the rule we had where oxygen has an oxidation state of -2. So we know these two oxidation states. So what we have to do is solve for the unknown oxidation state. So let's look at this example for nitrogen. Now we see that nitrogen can have a vast variety of oxidation states. There is no specific rule. For nitrogen, there's no specific rule for nitrogen. As sulfur, as phosphorus, as a lot of compounds that you will come in contact with, there are no specific rules for those. But we do know what group 1A and group 2A, we know their oxidation states. We know what generally hydrogen is going to be. We know generally what oxygen is going to be. So we can use those to solve for the unknown oxidation states. The unknown oxidation state of an atom in a compound or molecule. Okay? So, what I'm leading up to is you will always know one less oxidation state in a compound when you're dealing with atoms. So let's go back and just look at HNO3. Write this example out. HNO3. Okay? So, we have 1, 2, 3. We have 3 atoms. We know the oxidation state for hydrogen is +1, and we know the oxidation state of oxygen is -2. So we have 3 atoms in this compound, and we will always know one less than the number of atoms we're given in a compound. So we have 3 atoms here, and we will know one less atom. So we know 2 atoms. We know the oxidation state for 2 atoms. We know this. So this is the routine that these problems will follow. So we have 3 atoms. We know the oxidation state of 2 of them, so we can calculate the third using some basic algebra. That's what I was leading up to. Okay? So, if you're asked to determine the oxidation states or the oxidation number for each atom in HNO3, well, hydrogen is equal to +1. Oxygen is equal to a -2. We know this without doing any work, just from our rules, right? Right. So what we can do now is we can set up an equation. So let me rewrite this again. HNO3. Okay. So the first thing we want to do is we want to set up an equation. And this is a little bit different than what the book does, but I like to do it this way so you can follow exactly what I'm doing. So we have hydrogen plus nitrogen plus 3 oxygens. I can put that in parentheses. Must equal the overall charge. HNO3 is neutral, so we must set that equal to 0. We must set that equal to 0. Now, all we want to do is simply plug in the oxidation numbers that we know. Well, hydrogen is what? +1. We don't know nitrogen, but what? We do know oxygen. But how many oxygens do we have? We have 3. So that must be 3 times a minus 2. And that is equal to what? 0, the overall charge of the molecule. Okay? So, we can say that +1 plus the N plus a minus 6 equals 0. So you don't need that +1 to know that that's positive, and you don't need that minus 6. So we can say what? N minus 5 is equal to 0. So when we solve for nitrogen, the oxidation state in HNO3 is what? +5. And it's exactly what we have here in the table. +5. So what? We knew one less in the compound. We knew one less of the oxidation states of each atom. We knew hydrogen and we knew oxygen. And we had to solve for nitrogen. Okay? So let's try another one. Let's see if you can follow this. And I'll stick with a couple of nitrogens because we have a table over here with the various oxidation states nitrogen can have. So let's do N2O, and you remember the name of that, I'm sure, as dinitrogen monoxide. So, what do we know? And I'm not going to write that equal like I did before. We know, I'm just going to put that above. That's a common practice to write this above. We know the oxidation state of oxygen is -2. So let's set up our equation. We have 2 nitrogens plus, what is the next atom? Oxygen. So we're through with our atoms, and it must equal the overall charge of the molecule, which is 0. Dinitrogen monoxide is neutral. Okay? So, and I'll draw a line through here so you can distinguish that from oxygen. This is 0, that's oxygen. So we know the oxidation state of what? Oxygen. So 2N plus a -2 equals 0. So 2N equals 2. Divide both sides by 2, and the oxidation state of nitrogen and dinitrogen monoxide is +1. Okay? So, let's work some other examples. Let's say let's try dichromate, the dichromate ion, which is Cr2O7 with a 2 minus charge. Well, let's do this. Let's come down and make our equal. So this must equal a minus 2 because that is our charge, right? Now we have oxygen. We have 7 oxygens and we have 2 chromium. Okay, so now we must solve this equation. Well, we don't know the oxidation state of chromium, but we do know the oxidation state of oxygen. So we can write 2Cr plus 7 times a minus 2 must equal what? Minus 2, because it must equal the charge of the ion. So 2Cr minus 14 equals minus 2. And we have 2Cr equals 12. And we divide both sides by 2. And the oxidation state of chromium is plus 6. Now, one easy way we can check that is we can say we have 2 chromiums at an oxidation state of plus 6, and we have 7 oxygens at an oxidation state of minus 2. Now, does 12, that's where that number comes from, minus 14, does that equal to a minus 2? Well, yes, it does. So that lets us know that we calculated the oxidation state of chromium correctly. So you can see how simple this is once you know your rules and how to set things up. Let's do SF6. And you will come to find out when we do Lewis structure that sulfur can have many different oxidation states. Okay? So, fluorine mostly prefers, and this may not have been in your rules, but fluorine would mostly prefer a minus 1 oxidation state. I think there is an example in the book like this. So, SF6 is molecular. It has a overall charge of 0. So let's set up our equation. We say sulfur plus 6 fluorines, you can put that in parentheses or not, must equal what? 0. The overall charge is minus 1. So what is the oxidation state of fluorine? It's minus 1. And we set that equal to 0. So sulfur plus 6 times the negative 1 equals 0. So now we have sulfur minus 6 equals 0, and sulfur will equal a plus 6. So the oxidation state of sulfur and SF6 is plus 6. So we can write that at the top. Plus 6. So you can double check that. Does plus 6 plus 6 times a minus 1, does that equal 0? Well, yes, it does. Your plus 6 for the 1 sulfur atom, and 6 times a minus 1 for 6 fluorine atoms, and that equals a 0. I hope you're getting the hang of this. So let's try writing black once. Let's try copper 2 sulfate. Well, this kind of gives it away because we know that copper 2 plus SO4 with a 2 minus charge, that gives us copper 2 sulfate. So in this case, copper would be 2 plus. What is the oxidation state of sulfur in the sulfate anion? We have SO4 with the 2 minus charge. So we have sulfur plus 4 oxygens equals a minus 2. So sulfur plus 4 times minus 2 equals minus 2. And we have sulfur minus 8 equals minus 2. And sulfur is equal to plus 6. So that would be plus 6. So we have plus 2, plus 6, and minus 2. Now we can do a quick check and see is that correct. Well, we have 1 copper plus 1 sulfur, and we have 4 times minus 2. So 4 times minus 2 is a negative 8, and a plus 6 plus a plus 2 is a plus 8, and that sums up to be what? 0. So 0 is our overall charge. This is an ionic neutral molecule, so we know our oxidation states are correct. For copper, it's plus 2, sulfur being plus 6, and oxygen being -2. All right, let's try one more. HClO2. So you remember from our rules that hydrogen, in most cases, the majority of cases, the cases we will deal with, will be +1. Oxygen is -2. So what? We must solve for the oxidation state of chlorine. See how we always know 1 minus the number of atoms, their oxidation state? We know the oxidation state of hydrogen. We know the oxidation state of oxygen. We don't know the oxidation state of chlorine. So we must solve for that one. So let's set up our equation again. H plus Cl plus 2 oxygens, not 1 but 2 oxygens, must equal a -2. We must take in the contribution of both oxygens, not one, but both oxygens. Anytime we have a subscript here, we must represent it as a coefficient in our equation. Okay, so hydrogen plus chlorine, and let me go back and say, we know the oxidation state of hydrogen is +1 plus chlorine plus 2 times the -2 must equal, I made a mistake here, that should be 0. Okay, that should equal 0. Now, so we have chlorine plus a -2 plus 1 gives us a -3 must equal 0. And when we solve for the oxidation state of chlorine, we say chlorine must equal a +3. Let's look at our check. We have HClO2. So the oxidation state we know of hydrogen is +1. We found chlorine to be +3, and oxygen is -2. Well, we have 2 times a -2. So when we sum all these together, does that equal the overall charge of 0? Well, 1 plus 3 is 4, plus a -2 does equal 0. So we know the oxidation state of chlorine that we just found is correct. All right. Let's look at H2CO3. So the oxidation state for hydrogen is +1. Oxygen is -2. So let's write out our equation. 2 hydrogens plus carbon plus 3 oxygens must equal what? 0. This is a neutral molecule. Okay? So we know the oxidation state for hydrogen, and that's +1 plus carbon, and 3 times -2 must equal 0. So what? Our unknown is carbon. So we have +2 plus carbon plus a -6 equals 0. So carbon -4 equals 0. So the oxidation state of carbon in H2CO3 must be +4. Now, let's double check that. H2CO3. We have a +1, but we have 2 of those, and we have +4, and then we have 3 oxygens at a -2 each. Does that sum up to be 0? Well, we have 4 plus 2 gives us what? 6. So that's 4 plus 2 hydrogens at an oxidation state of +1 each gives us 2. So that's 4 plus 2 gives us 6. Plus a -6 that equals 0. So the oxidation state that we assigned for carbon was correct. All right. Let's do one more. Let's try, this one I haven't done before. Let's try S2O3 with a 2- charge. Okay, so we know the oxidation state of oxygen is -2, so we would be solving for sulfur. So let's write our equation. 2 sulfurs plus 3 oxygens equals a -2. 2 sulfurs plus 3 times a -2 must equal a -2. That's 2 sulfurs plus a -6 must equal a -2. And we have 2 sulfurs equals a +4 now. Move 6 over here, and 6 minus a 2 gives us a plus 4. So divide both sides by 2. The oxidation state of sulfur in S2O32 minus is a plus 2. Let's check that. S2O3 2 minus. So we know that oxygen is minus 2. That's a straight give me. So we found the oxidation state of sulfur to be plus 2. But we have 2 of those, right? And we have 3 oxygens. So does a 4, positive 4, plus a minus 6, does that equal our charge of a minus 2? Well, yes it does. So we know the oxidation state that we found for sulfur is correct. Alright. Now, let me give you some reminders. Going back to iron, if we had iron solid, aluminum solid, copper solid, these are all in their elemental state. So if you were asked what the oxidation number of these were, the oxidation number is 0 for all of these. What about hydrogen gas? What about nitrogen gas? What about oxygen gas? These in their elemental state of the same atom, the oxidation number is 0. Let me draw a line through that so you don't confuse that with oxygen. Don't say diatomic oxygen is minus 2. That is incorrect. Its oxidation state or oxidation number is 0. Okay? Now, what if we had Fe3+? And you could put a state beside that, aqueous, aluminum, 3+. What if we had copper, 2+? Well, the oxidation number is equal to the charge. So this oxidation number would be +3. This oxidation number would be +3. This oxidation number would be +2. What if I had nitrogen with a 3- charge? this oxidation state or oxidation number would be 3 minus. Okay? So you have to go through and practice those examples and be clear about what you're doing. You must be very clear about what you're doing and have an understanding of the rules. So, for your homework, you will do the following. You will determine the oxidation number of each atom in the polyatomic ion, compound, or molecule, or complex ion. So, number one that you have to do would be MnO2. Number two, FeCN6 with a 3 minus charge. Number three, H2SO4. Number four, SO2. Number five, SO3. Number six, CrO4 with the 2 minus charge. Number seven, aluminum liquid. Number eight, Pb plus 4. Number 9, H3 PO3. Number 10, H3 PO4. Number 11, P4. Number 12, NH4 plus. Number 13. Cu solid. Number 14. PO3 with the 3 minus charge. Number 15. AS O, the AS2. Let me write that so you can see. AS2O5. Number 16. SiO2. Number 17. SH2. Number 18. SH4. Number 19, S8. Number 20, FeO. So these 20 will be due on Monday at the end of class. Please show all your work and how you came up with the oxidation number of the unknown atom. And if you have paid attention to the video, you know what I mean by the unknown atom. And show each step and make it clear which atom has which oxidation state.